Okay, so in the rewind, I noticed a lot of people were completely struggling. And I think that's just because it's been like 3 weeks, right? So how many of you guys, once you figured out number 9, could do 10 in like a split second, right? All right, so let's remind ourselves. These 9 and 10, I said you only have to do 2 of them, and I said I would do 9 and 10 before I would do 11 and 12 if I were you guys. Why? Why are 9 and 10, quote unquote, easier? Gabe? It's already plotted for you, basically, because it's in what format? Victoria? It's in y equals mx plus b, which means you know the slope and the y-intercept. So, for example, in number 9, what's my y-intercept? 3. So then I plot that at 3 on the y-axis, and then my slope is what? Negative 1 over 3, which means I go down 1, 3 to the right. Perfect. What if I wanted to go the other way? Positive 1, 3 to the left. Very good. So you can put the negative on either one. You can put the negative on the 1 or the 3, but you can't put it on both. All right? If it goes on both, then it would actually be a positive. So there's our line. Okay, now, what if I didn't give you 9 and 10, and you had to graph 11 or 12? What would you do there?
You would have to give up.
You would not give up because you guys are persistent.
You would have to subtract x.
Okay, so you have to subtract x from both sides because you need to do what?
You need to leave y by itself.
I need to get y by itself, right? So we've got x plus y equals negative 3, and I need y by itself, so I subtract x. What do I have now here?
Y.
Just y, because those x's cancel each other out. So then how do I write this? You could do negative 3 minus x, or you could do negative x minus 3, because you want it in what format? Y equals mx plus b, so you want the x first. It doesn't really matter. This is also correct. It's just in the incorrect format, I guess. So if I don't have a number in front of x, what do I put in front of it? A 1, so it's a negative 1 over 1, always over 1. Just put it over 1. And then what's my y-intercept? So where do I start? At negative 3. And then my slope tells me I go down 1 over 1. Down 1 over 1. If I want to go backwards, I can go up 1, left 1. All right, so can you do all of these? Absolutely. All right, if they're not in slope-intercept format, you just have to get y where? By itself. All right, and typically to do that, you're just going to have to subtract the x. All right? Okay, so it has been a long time. I think honestly, if we counted the days, it's probably been over 3 weeks since we've actually had class together with midterms. So it's been a long time, which means I totally understand if you guys look at this stuff and you're like, I don't know how to do this. What I want you to remember is that even though it's been 3 weeks, again, think about as soon as I talked about number 9 with most of you guys, 10 was super easy, right? You know all this stuff. The next couple weeks are just about reactivating what you've already been doing. So just triggering reminders for yourself on what you already know. I don't know what I said. But anyway, so reminding yourselves of what you already know and using that for what we're going to be learning now. And what we're moving into now is systems of equations. And so when we talk about systems of equations, that's what this is. A system of equations is a set of 2 or more linear equations containing 2 or more variables. So basically, let's go back for a second. What does the word system mean? When I say I have a computer system, or there is an ecosystem, or I can't think of another. It's like a group. All right, what do you mean by that? Exactly. So an ecosystem, you guys studied ecosystems in science, right? Yeah. So give me an example of an ecosystem. Earth? That's very broad. Let's think of like a pond, right? If there's an ecosystem of a pond, what is working together in that pond?
Fish.
There's some fish there, and the fish probably are eating what? Algae maybe, and the algae is doing what?
Swimming.
Swimming, so floating in the water, right? But everything's interconnected and it's all working together. There's a reason I'm not a science teacher, all right? So everything's working together. That's why it's called an ecosystem, because it interacts with each other. The fish could not live in the system if there weren't the algae there, right? So you need all the parts. So when we talk about systems of equations, we're talking about equations that work together. All right, so this system of equations contains the same variables, and you're going to try to find a solution for that system of equations. When you find a solution for a system of equations, we say basically the solution is an ordered pair, x, y, and we use the word satisfies, that satisfies both equations. What do you think that means, to say something satisfies both equations? It can go into both of them, exactly. So when something is satisfied, that means it works, it's done, right? If you have lunch and you leave feeling satisfied, that means you ate enough, you're full, right? It worked, that lunch worked for you. You had a sandwich, some chips. Okay, all right. So that lunch satisfied you because it did its job, right? So when we talk about an ordered pair that satisfies the equations, we're talking about an ordered pair that does its job. So like Micah said, one that works, right? So I need something that works for both of these. So take a look then, for example, at this question, which says, is 4, 9 a solution to this system of equations? 4, 9 is my ordered pair. How would I figure that out? How would I answer that question? You plug both of them in, and you see if it works, all right? So let's call this equation number 1, and let's call this equation number 2. In number 1, if I plug that in, what does that look like? Y equals 2x plus 5. 9 goes in for y, and then 2 times 4 plus 5. All right, 9 equals, what's 2 times 4? 8 plus 5. What's 8 plus 5? 13. Okay, did that work? No. So then is this a solution? No. All right, that's not a solution. Okay, if that had worked for this first equation, would you be done? No. No, why not? You got to solve the other one. So, Alfonso, you'd have to plug it in for the first one and the second one. Why did I only have to plug this one in for one? I'm done already. How come I'm done already? It didn't work. As soon as it's not a solution, you don't even need to bother trying the second one because you know it's not going to work for both of them. Even if it works for one of them, if it doesn't work for both, it does not satisfy the system of equations.
So one more worked, you have to go ahead and solve the second one.
If it worked. If one worked, you have to solve the other one. Okay, go ahead and try at your seats, try this first one, the 4, 1. So here's your ordered pair. Go ahead and see if that is a solution to the system of equations. If you have an answer, let me know, and I will come around and check it. You all right? Okay. So did that work for both of them? So then that's the solution, yes or no? Good.
On my arm.
Yeah. Good. So yes or no? Is that a solution?
Yeah.
Yeah. Good. Good. So did it work? Good. So you would say yes or no? All right. So did this one work? Mm-hmm. Yeah. So is it a solution? Yes or no? Make sure you guys are putting yes or no. Good. What do you mean it has to be the same? Like both of them have to work, yeah.
After you solve it, it has to be the same?
Yes.
Yes.
Good. Okay, so how would we do this? Victoria, what's the first thing we should do here? What's the first thing we should do to see if this is a solution to the system? plug in which one to which equation? Does it matter which one you do first? No, pick one for us then. So x plus 2y, so what would that look like if you plug that in?
4
plus 2
times y. Times 1.
Equals 6. Okay, what's 2 times 1?
2.
So 4 plus 2 equals 6. Is that true?
Yes.
Good. 6 equals 6. So that one works. All right. And then what about the second one?
4 minus 1 equals 3.
All right. Is that true? Good. So does that work? So is this a solution? Make sure you put that answer. Okay? Because the answer to the question is yes or no. All right. Now, here's the deal. Do I want you to show your work? Yes, always. All right? Do I understand that you can probably do 4 minus 1 in your head? Yes. So if you can do these in your head and you want to do the mental math, that's fine. Just recall that if you do them in your head and don't show any work and then get it wrong, I can't give you any partial credit, okay? So make sure that you're always going back and checking your work. It doesn't really take that long to write it down. All right? So we would do the same thing for number 2. So in number 2, what would this first equation look like if I plugged it in?
2 times negative 1 plus 5 times negative 2. I mean, by 2 equals 8.
Okay, what's 2 times negative 1? What's 5 times 2? Does that equal 8? Yes, 8 equals 8, so that one works. All right, what about my second one?
3 times negative 1. 2.
What's 3 times negative 1? What's 2 times 2? What's negative 3 minus 4? Negative 7. Does that equal 5? No. So is this one a solution? So you say not a solution. Okay, you can also just put no. That's fine. Do not put no solution, though. Because there might be a solution. This is just not it. All right? Don't put no solution. This is not a solution, but you wouldn't say no solution because there might be a solution. It's just different than this.
So you put no?
You could put no. I'm not going to mark you wrong if you write no solution. Not a solution, because this is not a solution. But you don't want to put no solution because that means there isn't one at all. And you don't know that. Just put no. Just put no.
Just put one solution in.
No, because you don't know what it is.
But there's a check one. Or you put
But so if it's a solution, that means it works for both of them. So you can't say one solution because even though it works for this one, it doesn't work for the system. Okay, up at your boards before you go, I want you to do 3 of these. The blue numbers are your potential solutions, so that's what you're plugging in. So choose any 3 that you want to do. All right, so when you are finding out if it's a solution or not to a system, all you have to do is plug it in and test to see if it works for both. What would you do, though? What would you do if I did not give you this and I said, find the solution? Plug in random numbers until you found ones that work for both?
That would take too long.
How do you know it's ones?
Well, I got it.
Because you're guessing, right? And so that might work. Okay, how long will that process take?
A long time.
It could be really quick if you are the luckiest guesser in the history of guessers, right? But if you are not the luckiest guesser, how many of you guys would like to spend the next 12 years of your life trying to plug in random numbers to find a solution? I wouldn't, right? There has to be a better, easier way to do it. And there is. There's actually 3 ways that we're going to talk about. There's 3 ways to solve systems of equations that we are going to look at. They are graphing, substitution, and elimination. So we're going to talk about graphing today because it's what we just went over in the rewind. You guys are going to go over substitution tomorrow. We're going to talk about elimination on Monday. So there are 3 different ways to do it. And I said this to my last class, and I really think it's true. One of the biggest things that we're going to do in algebra this year is solving systems of equations, all right? A lot of what we did first semester, you guys had probably seen before. All right, solving system of equations is really one of the big 2 or 3 things that we go over in Algebra 1, so we're going to spend a lot of time on it. Yes, Gabe?
When you find big, it's like the hardest
Not the hardest. I don't think it's the hardest thing. It's just one of the things, if I had to make a list of like the 3 topics that I really want you guys to be able to do when you leave this classroom, that's one of them. It doesn't mean it's the hardest. I don't think it's the hardest. You guys actually know how to do all the pieces of it already. We're just putting some pieces together. All right? Now, as in most things in algebra, there's a lot of different tools that you can use to get to all the right answers. These are 3 of the tools for solving systems of equations. And we're doing graphing first because we spent most time on graphing recently. Okay? So, to graph a system of equations, again, remember, a system of equations is just a set of equations that work together, that use the same variables, right? So let's say, for example, that I gave you 2 equations and I asked you to graph them, and you graphed them and it looked like this. Where do you think the solution is? Where they cross each other, exactly. So the solution to a system of equations, when you graph them, is the spot where they cross each other, which in this case would be what? 2, 3. So that means rather than guessing and checking and trying to get your way to 2, 3, you don't have to do that. All you have to do is take your 2 equations, put them onto a coordinate plane, and figure out the spot where they meet. Okay? Now, let's say I gave you this. Y equals 1/5 x minus 4, and y equals negative 1/3 x plus 3. You'd have to plot it, right? You'd have to get a coordinate plane and you'd plot it. And what would you look for? The place where they met each other. And that intersection point is the solution. So rather than saying like, okay, well, let me try plugging in 1 and 2. Let me try plugging in 0 and 1. I don't want to do that because that's inefficient. It would work ultimately. You could try plugging in every number, but don't forget there are decimal numbers, there are negative numbers. You'd have to plug in everything. Rather than doing this, graphing is a simpler way to do it. All right, Brian, did you have a question? How do you graph it? Think about the rewind, right? How do you graph this one?
Oh, you start with negative.
Exactly. You start at your y-intercept, and then you use your slope, and you plot them onto a graph, and you see where they meet. Now, for the purposes of the ones that you're going to do in this classroom, they will be whole numbers. Okay? I'm not going to give you guys fractions and decimals to worry about. On your homework, you might see some fractions and decimals. Just round them to the nearest whole number. Okay? So that means you're not going to have ones that cross in spots that aren't whole numbers. If you do, round them. All right? So what Brian said is, how do you graph them? All right, so we'd take a look at this, and we would graph this first equation. We'll call it equation number 1. And then we would graph equation number 2. And these 2, these are actually the ones that you did in your rewind. These 2 are simple because they're already in what? Slope-intercept form. So if they're not in slope-intercept form, what's the first thing you have to do? Get y by itself. All right, so right here, these are the steps written out for you. You don't have to copy them down. They're obviously already on your slides. These are the steps written out for you. The first step is optional. The first step is change the equations to slope-intercept form if you have to. Sometimes you don't have to do that. All right, so you might not have to do step number 1. In this set of system of equations, are these already in slope-intercept form? Yes, y is already by itself, so you don't have to do step number 1. So then you just do steps 2 and 3. Steps 2 says graph it onto a coordinate plane. So here's my first equation. Where's the y-intercept there? Negative 3. So I start down here at negative 3. And then what's the slope here? 1 over 1. So I go up 1 over 1, up 1 over 1. And this is the blue line. So that blue line is this equation right here. This is equation number 1. All right? Equation number 2, where's the y-intercept? Negative 1. So we start right here at negative 1. What's my slope? Negative 1 over. So that means I go down 1 over 1, down 1 over 1, down 1 over 1. So that's my red line. This is equation number 2. Does this one have a solution? Yes, because they cross each other, right? Where do they cross each other? 1, negative 2. So this right here is the solution, which means you could plug in 1 for x and negative 2 for y, and that would work for both of those equations. So when you're graphing, you're looking for the spot where they cross. So step number 3 says find the intersection point. Step number 4 is just checking your answer, so plugging it back in to be sure that it works. All right? So to do that, if I plug in 1 for x and -2 for y, it's going to work for both of those. So that's a solution to that system of equations. All right?
If they do not cross, then it's not.
Okay, a couple things. If they do not cross, you might just need to keep going on the graph. So you kind of have to look at it and say like let's say for instance, let me put a blank one up here to answer that. Okay, let's say for instance this was my coordinate plane, and I had 1 right here, and I had 1 right here. All right, if I stop them there, it looks like they don't cross, but are they ultimately going to cross? Yes, if I keep my blue one going. So what I mean by keep going is keep following your slope to make your line longer. So sometimes you'll have to do that. However, sometimes you end up with ones like this. All right, I didn't draw that perfectly. But that blue and black line look like they might be what? Parallel, which means what? They never touch. So if they're parallel, they never touch, then what do you think that means? There's no solution. They will never touch. All right, there's no solution because they're never going to touch each other. So that only happens very infrequently. All right, that won't really happen very often, especially for the ones that you're doing. So just make sure your lines are long enough. You can always keep going, and you can always go backwards with slope. Okay, so let's try one. I need you guys all, if you have your eyes closed right now, you need to open them, because this part is where it gets a little bit challenging. So I need you guys to pay attention. I know it's hot in here. All right, I know it's hard to stay awake, but I know you guys can do it. Okay, so which one do you want to start with here? Let's call this one equation number 1 and this one number 2. Let's do number 2. Why'd you say that? I agree with you.
Everything's already there.
Everything's already in order. It's easier. It's in slope-intercept form. So where do I start? At +1. What do I do from there? Go down 1, 2 to the right. Perfect. Go down 1 and 2 to the right. I'm going to do it again because I have more room. So down 1, 2 to the right. What if I want to go backwards? Up 1, 2 to the left. Good. Why do I maybe want to do that? Why do I want to...
The first one is like in a different angle.
Exactly. If I do it the longest that I can, then I'm not going to miss a spot where they cross. Okay, so there's equation number 1. Now equation number 2. Equation number 1 is x plus y equals 0. So what do I have to do before I can graph that? Get y alone, which means I need to do what? Subtract x minus x. And I end up with y equals, because those go away, -x plus 0. Perfect. Which means my y-intercept is what? 0. So I start right here at 0. And then my slope is what? -1 over 1. Perfect. So then I go down 1 over 1. Down 1 over 1. Down 1 over 1. Am I getting any closer? No? So then what should I do? Go the other way. Go up 1 over 1. Up 1 over 1. Up 1 over 1. Did I get a solution yet? Where do they cross? -2, 2. So there's your solution. Okay? So that means you could plug those in for x and y and it would work for both of them. All right? So is there a good amount of work for each of these problems? Yes. Is it faster than guessing and checking through infinity?
Yes.
Probably. You can try to guess and check. You can do it however you'd like to do it. I would not recommend that. All right? So when you're graphing, one of the things that's really important is drawing a really careful coordinate plane or using a blank coordinate plane. So for these practice problems, I think it's easier if you do them at your seats on these coordinate planes because I think it's hard to draw a perfect one. But if you'd like to go to your boards to do these practice problems, that's fine. I just want you to do one of them. Just do one of the practice problems. All right? And once you have it, thanks. Can you say that louder? No, I'm just kidding. All right. Once you have one of them, let me know so I can check it, and then you guys can do your exit ticket, okay? Again, if you want to do them at the board, you can. I just think it's easier to do it on an actual coordinate plane. I'm going to get you guys bigger coordinate planes so that you don't have to use, magnifying glasses, but I don't have them today. So I will get those for you, and I'll keep, 200 copies in the room, so if you have them, if you need them. Okay, so do one of the practice problems.